Hello Calculus and welcome to 10.2. This is first order differential equations, linear, and this is just a basic introduction so you kind of get an idea of what they are. We're not really going to use them much. We're not going to do much application. This is just so you have seen it. This is actually the last section before your WIT final. So next you'll be doing your review on that. So hopefully we are ready. All right, get your stuff out. You'll need a calculator and let's go. Okay, we're going to be doing an integrating factor, which is something new. And then I'll show you the steps for doing this. The first one is just an example. So you should actually know how to do this here. I was just kind of giving you a very rough idea. So when you look here, it has to be in this equation. We have to have dy dx by itself. There will be a function times y equals a second function. All right? So when we look at this, we have to get this in this form. So the y has to be on this side, but this 2x to the fourth is actually the qx and needs to move over. Also, when we do this, the x has to be gone. So we need to divide by x also. So we're going to divide by x, move this guy over to the other side, and we've got by dy dx by itself, we have 6y over x equals negative 2x cubed. Now this is really 6x to the negative 1 times y. This is the function, the p of x, and this is my q of x. Now there's a formula for figuring out what we actually have to multiply by, because we got to multiply in order to get a derivative over here. Well, right now we're just going to take my word for it. There's an x to the 6th is what we multiply every single term by. Now when you watch, if you take x to the 6th derivative y, right? So we're taking what we multiplied times y. Now, when we take this guy's derivative using our product rule, it's 6x to the 5th times the y, right? The derivative of the first times the second, plus the first times the derivative of the second, the dyx. This is our derivative of x to the 6th y. Kind of cool, right? And we'll show you how to calculate that. So that means this entire thing is the derivative of x to the 6y, which is what we calculated. And that equals our qx, a negative 2x cubed. This again should not be here. Now, if I take the antiderivative of both sides, well, the antiderivative of a derivative is just itself, the x to the 6y. Now I have to do the antiderivative of this, so we add 1 and divide by 10, which is over here, plus c, don't forget. So we simplify, and now y has to be by itself, so we divide everybody by x to the 6th, and this is our final answer. Kind of weird, right? All right, are you ready for the steps so you can do this on your own? I'm not sure what happened there. All right, we have the same formula. Now, the integrating factor, or what we multiplied by, is always calculated by taking e to the antiderivative of px, and px is the function that is in front of the y. Okay, the dy has to be by itself. So step 1, we make sure that this is true. We've got the function times y equals a second function. Must be in that form, right? Next, we find the integrating factor by taking e to the integral of this function here in front of the y. We multiply each term by whatever that turned out to be. And then what is ever on the right side is going to be the derivative of our ix, our integrating factor, times y. And then we integrate both sides and solve for y. Okay, doesn't sound too bad, right? Okay, we're going to start off one with what's actually not in terrible shape. So dy dx is by itself. We're good. 2xy, so this is the p of x1 because it has the y with it. And this is the q of x because it does not have the y, which means this one needs to be on the other side of the equation. So we just moved it over. Second step, we take the p of x, the 2x right here. So now we're doing our integrating factor. So this is hard to read over here. We're going to take e to the antiderivative of 2x dx. Well, we know the antiderivative of 2x dx is x squared divided by 2, right? And the 2's are going to cancel, so we're going to get e to the x squared. This is what we multiply every term by. So now we take this function up here, where we started, and we multiply everybody by ex squared. So once we do that, we have ex squared times the dy dx. We have the 2xy times the ex squared. We have the x e to the negative x squared times e to the x squared. This side here is the derivative of e to the x squared y. Now, let's make sure we understand that. What is this derivative? So the derivative of the e is itself times the derivative of the exponent, which is the 2x times the y, plus the e to the x squared times the derivative of y, which is dy dx. Does it work? E to the x squared, dy dx is here. E to the x squared, 2xy is here. We have done our work correctly. This is the derivative of the integrating factor times y. Good so far. So now we take and we rewrite the right side as the derivative of e to the x squared y, because that's what it is. And this is what was left over. Well, now e to the x squared times e to the negative x squared, remember we just add exponents? Well, x squared minus x squared is 0, so their e's are going to cancel. All right, now we take the antiderivative of both sides. Well, the antiderivative of the derivative is itself, right, because we're working backwards. Okay, now the antiderivative of x is x squared over 2 plus c. Should be good. So now we're to this equation. We have to solve for y. So we divide everybody by ex squared. And we've found our equation. Next, they could ask you to find c. They'll give you what things are worth. So they're going to say, hey, find y if y equals 3 when x equals 0. So this is a point. So we plug in the 0 for the x's. We plug in the 3 for the y. Well, this is 1. This is 1. 0 divided by 2 is 0. So we got 0 plus c up here, which is just c. We take the 3, we plug it into our original, and that is our final equation. All right, I want you to pause and try yours. Let's see if we got enough room here. All right, the first thing you should have said is, hey, my dy dx isn't by itself. So you must divide everybody by 2. So I've got dy over dx. That needs to be minus 3y. Okay, minus e to the x over 2 equals 0. Well, I'm looking at this. This is the y, so the p of x is 3. This is the q of x since it does not have a y, so we moved it to the other side. So now you got dy dx minus 3y equals e to the x over 2. Now we got to calculate our integrating factor. So what is the integrating factor of x? Now remember that's calculated by e to the antiderivative of, and this time we just have negative 3. Well, the antiderivative of negative 3 is just negative 3x. So this is our integrating factor. So we got to take everybody times e to the negative 3x. Let's change color. So now this gets taken times e to the negative 3x. This gets taken times e to the negative 3x. And this gets taken times e to the negative 3x. All right, when we do that, this is our derivative. So this is the derivative of e to the negative 3x times y. That has to equal, well, if we add this, that's e to the negative 2x over 2. Okay, now, when we're looking at this, let's double check. Our derivative of e to the negative 3x times y. So the derivative of the first is e to the negative 3x times negative 3, right here, times y, plus the original times the derivative of dy dx, which is this one. So they both work. You're using just your product rule here. Okay, now, since we have that done correctly, we do our antiderivative. We do the antiderivative of both sides. Well, the antiderivative of a derivative is itself. Now, the antiderivative over here. So the antiderivative of e to the negative 2x is itself divided by the negative 2, or the derivative of the exponent. So you should have gotten e to the negative 2x over negative 4. Or, I'm going to put the negative alpha, negative 1/4. And don't forget your plus c. Okay, your next step is you got to solve for y. So now we have, let's change colors here again. Great. We've got y equals, I'm going to put the minus 1/4 out front just to help us out here a little bit. So we got e to the negative 2x in the numerator and e to the negative 3x in the denominator, plus c over e to the negative 3x. Well, when you do this, you're subtracting the exponent, so minus 2 minus negative 3 is a positive 1. So we got e, and we've got minus 1/4 e to the x. A negative exponent belongs in the numerator, so this is just e to the 3x c is where we are at to this point. Next, they gave us 0 and 5. So we take 0 and 5 and we plug them in. So we're going to plug in the 0 for the x and the 5 for the y. So we get 5 equals negative 1/4 e to the 0 plus e to the 3 times 0 plus c. Well, we know anything to the 0 power, oops, that was times c, I'm sorry. I wrote it wrong. I was thinking too far ahead. Okay, anything to the 0 power is 1, so that's there and there. Now I just got to add the 1/4. Well, 5 plus 1/4 is just 20 plus a 4th, so we got 21/4. And this is equal to c. So now we rewrite our equation, and we should get, so you're going to rewrite this one right here. So we got y equals, actually this one would be easier. I equals negative 1/4 e to the x plus 21 e to the 3x, so that's your numerator, all over 4. And that's it. I hope you did well. All right, if you have questions, make sure you post them. I wanted to go over one more start. I think it's in your homework. We have x dy over dx plus 2y equals x squared plus 6x. Now, you know to get dy by itself, so you just divide everybody by x. So you got dy dx plus 2, I'm going to write this as x to the negative 1, y equals x plus 6. This entire thing is your q of x, and right here is your p of x, just to kind of help you out with that problem. I hope you do well with it after that. All right, good luck. Post questions if you have any, and I hope you enjoy it. Next is our review for the final, or the WIT final, I should say, not the high school.